Hey, Wagwan. It's Mr. Garfield here, and we're going to do another CSEC Mathematics past paper question on circle geometry. All right, we're focusing on section 8, that is geometry and trigonometry. All right, and here we have a past paper question from the May June 2019. All right, this is a past paper question. Let's do this question here. It says that the diagram below not drawn to scale shows a circle, all right, with the center O, the line DCE here on the outside is a tangent to the circle, and the angle ACE, all right, ACE, that's this angle here, is 48 degrees, and angle OCB, which is this angle here, is 26 degrees. Okay, so they gave us that, and they have asked us to calculate some angles here. All right, they asked us to calculate 6 angles. Let us do the first one here. All right, the first one says to calculate the angle ABC. So let me just write the solution down here. All right. So I'm now going to scroll down. Great. So we're going to write the first part of our solution here. So this is part 1, solution. Okay. And they've asked us to calculate the angle ABC. All right. A is here. All right, B, C, so they're talking about this angle here. Okay, what do we know about that angle? How do we calculate that? Well, let us observe these angles here. All right, so we're going to look at these angles here. This chord here, which is the chord AC. All right, and we're going to also look at the tangent. Okay, and that's going to highlight up there. Right. So there's a theorem which says that the angle between the tangent and the chord is equal to the angle in the opposite segment. Okay? So it means that this angle here, right, this angle here is actually 48 degrees. Okay? So what we're saying is that the angle between the tangent and the chord, all right, which is the angle in that segment there, okay, is equal to the angle in the opposite segment. So the opposite segment here, all right, is over there. All right, the angle in the opposite segment is there, which is the 48 degrees. Okay, so our angle ABC is 48 degrees, and the reason is because the angle ACE, which is the 48 degrees, is between the tangent DCE and the chord AC. All right. So because this angle 48 degrees is between the tangent and the chord, it means that it is equal to the angle in the opposite segment. Okay. So the angle in the opposite segment is the angle ABC, which is 48 degrees. Let us write our solution here. All right. So we're saying that the angle ABC is equal to 48 degrees. Okay. And my reason is the angle ACE, okay, the angle ACE, which is between, the angle, which is between the tangent, sorry, all right, the angle ACE, which is between the tangent DCE, and the chord, AC is equal to the angle in the opposite segment. In the opposite segment. Okay, great. Now, this word opposite, you might see some persons have it as alternate segment, all right, instead of opposite segment. Okay, many of the times this is referred to as the alternate segment theorem. All right, so we're now finished with part one of the questions. Let's just write part two solution here. Okay, part two solution will be there. Let's just look at what they have asked us to calculate for part two. Part two says to calculate the angle AOC. All right, so let me just erase this here. So we know that this angle here is also 48 degrees. And they have asked us to calculate the angle AOC, which is this angle here in red. All right, that angle there. Okay. Now, what do you know about this angle? All right, we're going to observe this angle here, and the chord AC. All right, the chord AC. You recognize that these two angles stand on the same chord, which is AC. Okay, so whenever that is the case, it means that the angle at the center, which is the angle AOC, is going to be equal to 2 times the angle at the circumference here, which is the 48 degrees. All right, that is the angle ABC. Okay, so I can now come down here in my solution and say that the angle AOC is equal to 2 times the angle at the circumference ABC. Okay, so this is now equal to 2 times the angle ABC, which is 48 degrees, and that is equal to the angle AOC is equal to 2 times 48 degrees, that's 96 degrees. All right, and let us write our reason here. So our reason is that since the angle AOC and the angle ABC both stand on the same chord, all right, on the same chord. So since those two angles stand on the same chord, okay, the chord is AC, then the angle at the center, is twice the angle at the circumference, right? Is twice the angle at the circumference. Good. So that is our solution for part 2. So we're now finished with part 2. Let us now do part 3 here. All right, so we're going to write part 3 solution here. Great. So just look at what they have asked us to calculate for part 3. So we're now finished with part 1 and part 2. We're now going to do part 3, which is to calculate the angle BCD. All right, let's look at the diagram here. So let me erase these markings here. So we know that this angle here is 48 degrees. Okay, and we know that this angle here, AOC, is 96 degrees. Great. And they ask us to calculate the angle BCD. All right. The angle B is here, C, D, so they're asking us about this angle. Okay, that is the angle between the tangent DCE and the chord BC. Okay, great. Now, how am I going to find that angle now? Well, I know that the angle OCB, that's 26 degrees, okay? And I also know that this angle here, OCD, all right, all of that angle there that I've highlighted in blue, all right, that angle is actually 90 degrees, okay? How do I know that? Because the tangent DCE is perpendicular to the radius OC. You recognize that the tangent touches at the point C, the circle at the point C. C is what we call the point of tangency or the point of contact, okay? So we know that the tangent is perpendicular to the radius OC, so it means that it meets at 90 degrees, all right? So we're going to use that information now to find our angle BCD, all right? Because the bigger angle here is 90 and the smaller angle here is 26 degrees. So I can just subtract the two angles to get our answer, okay? So let me now do part 3 solution here, all right? So we are saying that the angle OCD is equal to 90 degrees, and we are saying that the angle, I just look back at it. So OCD is 90 degrees, right? Just look back at it. OCD is 90 degrees, and the angle BCD is what we're trying to find, right? But we know that the angle OCB is 26 degrees, okay? OCB is 26 degrees. Right. So our angle OCB is equal to 26 degrees. Okay? So it means that if that is the case, then our angle BCD is going to be equal to the bigger angle, which is OCD, minus the smaller angle, which is OCB. Okay? So I can now say that this is equal to the angle OCD, that's 90 degrees, minus the angle OCB, that's 26 degrees. So therefore, our angle BCD is equal to 90 degrees minus 26 degrees at 64 degrees. All right? Great. So our reason here now, our reason is that the tangent, all right, our reason is that the tangent DCE is perpendicular to the radius OC, all right, OC is the radius. So the tangent DCE is perpendicular to the radius OC. We used that information in order to calculate our angle BCD. So part 3 of the question is now completed. All right, so part 3 is completed. So we can just fill that into our diagram. All right, so let's just erase this here. So we're saying that the angle BCD is 64 degrees. All right, so this is 64 degrees here, all of that angle there. Great. Let's just now do part 4 of the question. All right, part 4 says to calculate the angle BAC, okay, the angle BAC. So they're talking about all of this angle here in red, okay, all of that angle there. Now, how would you calculate that angle? Well, let us observe this one here. The angle 64 degrees, okay, and we're going to look at the tangent here. All right, I'm just going to highlight that part of the tangent. and here we have a chord BC. Okay, great. And this is the angle that we're trying to find. So we can use the theorem which says that the angle between the tangent and the chord is equal to the angle in the opposite segment. Okay, so this is our segment here. This is the angle between the tangent and the chord in that segment. Okay, so the angle which is opposite to that segment is this angle here. Okay, which is the angle that we're trying to find, BAC. Okay, so it means that the angle there is 64 degrees as well. Okay, so that is our answer. So I'm now just going to scroll down to write our answer and our solution. Our answer and our reason, sorry. All right, let's scroll down here. This is now going to be part 4 solution. Great. So we're saying that the angle BAC is equal to 64 degrees. And the reason is that the angle BCD, all right, the angle BCD, which is between the tangent, all right, the tangent was DCE, and the chord, which was BC, all right. Since the angle BCD, which is between the tangent DCE and the chord BC, okay. So since the angle between the tangent and the chord, all right, then we know that they're equal, right? The angle between the tangent and the chord is equal to the angle in the opposite segment. Okay, so the angle which is between the tangent and the chord, okay, is equal to the angle in the opposite segment. All right, is equal to the angle in the opposite segment. And as I said, that you could also use the word alternate, all right, instead of opposite. Good. So that is part 4 solution. I'm now going to write part 5 solution here. All right. So part 4 of the question is now completed. Let's just look at what they have asked us for part 4. Part 5, sorry. All right, so part 4 is completed. And we're now going to look at what they have asked us for part 5, which is the angle OAC. Okay? The angle OAC. Just look for it here. All right. The angle OAC. They're talking about this angle here in red. Okay? Now, how would you calculate that angle? Well, I know that this line here, which is OA, and this line here, which is OC, both of those lengths must be equal because OA and OC are 2 radii. Okay? So if that is the case, then it means that this triangle that we have here, right, that triangle that we have here is actually an isosceles triangle, all right? And we know that in an isosceles triangle, the base angles are the same, right? We know that. So it means that I can call this angle here x, okay, which is what I'm trying to find. And I know that the angle x is the same as this angle here, which I'm going to call x as well. All right. So let's just calculate our answer here. All right, so we know that the base angles are x, okay? We have x here and x here, but how are we going to calculate the x? If we know that this angle here is 96 degrees and both of those angles are x's, then when we add those angles, we're supposed to get 180 degrees, right? So I'm going to use that information or that fact in order to solve the question, all right? So let us come down here now and write our solution. So part 5, okay? So when we add the x, and the angle AOC, we know that we are to get 180 degrees, okay? Now x plus x, that's just 2x, plus the angle AOC is equal to 180 degrees, all right? But what was the angle AOC? The angle AOC was actually 96 degrees, right? Great. So I'm now going to solve this equation for x. So what I'm going to do is to subtract both sides of the equation by the 96 degrees, okay? And if I do that on the left-hand side, I will have 2x. And if I perform the same operation on the right-hand side, I will have 180 degrees minus 96 degrees. So I can now say that 2x equals 180 degrees minus 96 degrees, which is 84 degrees. And now I have 2 times x is equal to 84 degrees. So in order to get rid of this 2 to find x, I will have to divide both sides of this equation by 2. So if I do that on the left-hand side, I will have x remaining. And on the right-hand side, I will have 84 degrees divided by 2. Okay? So when I divide 84 degrees by 2, I will now have x being equal to 42 degrees as my solution. Okay? Great. So therefore, what we're saying is that the angle OAC is equal to 42 degrees. All right? Great. And let us just write our reason here. Okay? The reason. So we stated that the base angles of an isosceles triangle are equal. Okay? So the base angles of an isosceles triangle are equal, okay? And we also use the fact that the sum of all the interior angles of a triangle is 180 degrees, okay? So let's write that as well. So, and the sum of all internal angles, all right? All internal angles or all interior angles of a triangle is 180 degrees, okay? And that is our solution for part 5 of the question. Great. So part 5 is now completed. We're now going to do the last part of the question, which is the angle OAB. All right, the angle OAB. So just write our solution here. So this is now going to be the last part of the question. All right, part 6. So that is the angle OAB, right? So let's write solution here. Great. So let's just look at it. OAB. Okay, so let us just erase these here. So we know that those two angles that we just erased are 42 degrees, all right? So that's 42 degrees, this is 42 degrees. Great. And they have now asked us to calculate the angle OAB, okay? The angle OAB. B. So they're talking about this angle here. All right, great. So how do we calculate that angle now? All right, how do we calculate that angle here? How do we calculate that angle? Yes, so how do we calculate the angle OAB now? All right, well, if you look at it carefully, we know that the angle OAC is 42 degrees, and previously we had calculated all of this angle here in blue, okay, which is the angle BAC. We had calculated all of that to be 64 degrees, right? So if I know that the angle BAC is 64 degrees and the angle OAC is 42 degrees, then it means that the angle OAB here in the red is going to be equal to the bigger angle, which is the 64 degrees, minus the smaller angle, which is 42 degrees. Okay? So let us write our solution down here. All right? Great. So we are saying that the angle OAB, all right, the angle OAB is equal to the angle BAC minus the angle OAC. All right, so the bigger angle minus the smaller angle. So the bigger angle was 64 degrees minus the smaller angle, which was 42 degrees. Okay, so therefore I can see that the angle OAB equals 64 degrees minus 42 degrees. That's 22 degrees. Okay, great. Now I'm just gonna write a statement here as our reason. Okay, so I'm just going to say since the angle OAC equals 42 degrees and the angle BAC equals 64 degrees, then it means that the angle OAB equals the angle BAC minus the angle OAC. All right? So I'm just going to write that as my statement. Good. So it means that we have now completed the final part of the question here. All right? Part 6. Great. So that is our solution. All right, so that is 64 degrees there, and our angle here in red is 22 degrees. All right, that angle there is 22 degrees. Great. So this is the end of the solutions for this past paper question. All right. I hope that it was helpful for you, and if it was, please ensure to like of the video, subscribe to the channel, and share the video with your friends. All right. With that being said, I am Mr. Garth Reed, student ambassador for the University of Technology, Jamaica, and I'm a mathematics teacher in training in the School of Mathematics and Statistics. I thank you for joining.